in this example, we are given that inside a lift which is oscillating up at 2 meters per second square, a loose bolt falls from its ceiling. If height of the lift is 2 meters, we are required to find the speed of bolt with which it hits the floor. We are also given that initial speed of lift is 5 meters per second in upward direction. If we just have a look on the physical situation, if this is the lift, it is moving up at 5 meters per second and its acceleration is say 2 meters per second square, and we are also given with the height of lift that is 2 meters. We are given that from the ceiling of lift a bolt falls. Now when bolt is detached from the ceiling, this bolt will also have an initial speed of 5 meters per second because it was attached with the lift which was moving at 5 meters per second. And after detaching from the lift, it will be in a free fall motion where it will have a downward acceleration g. We are required to find the time when it is going to hit the floor. Actually, lift is moving up also, so it will hit the floor somewhere here. But if the same bolt is observed by an observer who is inside the lift, he'll feel that when the bolt is detached, it starts falling freely with initial speed 0. So we can say initial speed of bolt as seen from lift or with respect to lift is, this initial speed is 0. If we calculate the acceleration of bolt as seen by this observer, we can say the bolt is falling freely with an acceleration g and lift is going up with an acceleration 2 meters per second square, which is opposite to g. So if we find out acceleration of bolt with respect to lift, the acceleration of bolt with respect to lift will be, this will be g plus 2, that is 10 plus 2, it is 12 meters per second square. Now relative to lift, if we find out the time at which it is going to hit the lift, say it is t1, so we can simply use in reference of lift, we can write h is equals to ut plus half at square. In this situation the height is 2 meters, initial speed is 0, so it is half, acceleration we take as 12 into t square, say time taken as t1. So from here you can see the value of t1 square we are going to get, this will be 6, 2 by 6, it is 1 by 3. That means the time at which the bolt will hit the floor will be 1 by root 3 second. At t equal to 1 by root 3 second, the bolt will hit the floor. Now in this duration we can easily find out what velocity it will gain. So if we find out velocity of bolt as seen from lift, if the observer who is inside the lift will be looking onto the bolt, say if it is hitting the velocity with say v1 with which it will hit the floor, so we can simply write v1 is equals to u plus at. So in this situation we'll take u as 0, so this will be just at, that will be 12 into 1 by root 3 second, that will be 4 root 3 meters per second. This is the velocity of bolt in the reference frame of lift which this observer will see. If we find out the net velocity with respect to ground with which it is going to hit the floor of lift, say it is v2, again we use v is equals to u plus at, but in this situation we take u to be 5 meters per second because when we observe the bolt from ground, it appears to be moving up with 5 meters per second and finally hit the floor in downward direction. So here we take it 5 minus acceleration, we take only g, it will be 10 into t is again 1 by root 3 second, because time remains same in all references which we have studied till now. So it will be 5 minus 10 by root 3 meters per second. So these are our answers to the question. And here we can say in this question, as we are just required to find the speed of bolt with which it hits the floor, so our answer will be 5 minus 10 by root 3 meters per second. But in some case we are required to find the velocity with which bolt will hit the floor as seen from the lift or in the reference frame of lift. Our answer will be 4 root 3 meters per second.